Delaware. So I always like to make a data table first when I see a word problem. Create a data table. Alright, so step one, write down the formula. Everybody see that? Step two, write down the data that you have. Step three, solve for the unknown variable. Now, Max, he's like super smart. He didn't show any work, right? He didn't show any work. He just showed you the answer. So, on the ACT, you don't have to show your work, but they're going to be able to test where you understand the information, or it wouldn't be the best measure we have to see how well you do in college. That is the ACT.
Wait, is that the answer?
Yes, so Max set up the problem right. He got 21, but it's actually 21 milliliters.
Then once the 50 milliliters graduated, contains 20 milliliters of water. What about that?
Right, it says, what is the final volume after the metal is added to the graduated cylinder? So then we take our 50 milliliters, right? Actually, it says a 50 milliliter graduated cylinder contains 20 milliliters of water, so it's actually going to be a 20 here. So I didn't read the problem, which is very important that you do, or you're going to get the wrong answer like we did right here. So it was 20. Nice question, Elijah. And so it ends up being what? Yeah, 41. 41 milliliters is your final answer. So this is a more technical problem than you'll see on the quiz this time, but you could see this problem on your next test, though. Over there. So this problem, coming from your homework last night, a 1 liter sample of carbon tetrachloride has a mass of 1.58 kilograms. What is the density of the substance in grams per centimeter cubed? So we write down what we're given: volume, 1 liter, mass, 1.58 kilograms. These are the conversion factors. I will give you these on a test. What you need to know how to do is place them correctly where the liters cross out. So that gives us milliliters. We need centimeters cubed, so 1 milliliter is 1 centimeter cubed. Milliliter crosses out, 1,000 centimeter cubed. 1 kilogram is 1,000 grams. Multiply that, 1,580 kilograms. Any question on just the conversion part? Don't forget the units. Slash. Excellent. So once again, Claire is one of your exceptionally smart students that is not labeling her numbers. So she's got the work right, but she didn't label initially. So she's doing problem 7. So if you're up here looking at like, okay. So if you're saying, where'd that 7 come from? It's a problem 7.
What is that, 1,000?
1,000 comes from its conversion factor. And she's converting this kilograms right here. See, 1 kilogram is equal to 1,000 grams. So she's setting it up properly. She's just not proving it to you, right? And she also knows, very good, that 1 liter is equal to 1,000 milliliters. Typically, the conversion factors are separate, like 1 liter is 1,000 milliliter, and then 1 milliliter is equal to 1 centimeter cubed. And people will convert it in 2 steps. She is like off the chart smart. She's doing it in 1 step. Yeah, because that's really good. I mean, I want to encourage you to do that because when she takes the ACT, she'll score higher because you'll have more time to do other problems. Wonderful water displacement lab. I'm going to choose an object out of the box, 2 of these. I'm choosing the blue one for Eastern. Who we playing on Friday? Yeah, PRP, the Panthers. So, on your balance, we have 2 balances up here. You're going to place the object in the balance. Make sure you have zeroed it prior to placing the object on there. So you hit the little 0 button, it'll go to 0. Hit the 0 button, it goes to 0. If you can't see it, I'll put it on the video. So you place it on there, and it's telling me 13.39 grams. And you're going to put that on your chart, not underneath the hypothesis chart. So I'm going to put 13.38 grams. So everybody see that? Now, I'm going to place some water in a graduated cylinder. Now, once you get the object in there, you have to pour the water back into, holding onto the object like that. You can't like reuse it, you have to pour the water out. So I'm going to take some water in this graduated cylinder, an amount of, looks like around, I'm going to say 29.0 milliliters. So when you write that on your volume chart, there's a volume chart that says initial, I, and then there's a volume chart that says final. So I'm going to say 29.0. Make sure you are measuring correctly. I will judge you on that if you're not measuring the graduated cylinder correctly. Then I'm going to take my object, 9.0, and I'm going to tilt my graduated cylinder to the side, like this. Does everybody see that? And I'm going to slide. I don't want the water to splash out because that's going to affect my volume. Everybody understand? If I drop it in there, it splashes out. Bad measurement. So then I'm going to have my displacement is around 41.2. Looks like 42.0. 42.0. So I'm going to take 42.0 minus 29. This is final minus initial. That's how you get change. Make sense? Final minus initial. So that's going to be equal to, what is that, 20, no, 10, 11, all right? No, 13. 13? Yeah. Yeah, 13. All right, so that would be your volume. So there's a last column for the volume, 13 milliliters, and you have your mass. Then you're going to find the density. Make sure you solve this for the correct number of significant figures. Make sense? Now, the first 2, I'm not going to grade you on whether you got it correct or not. What I'm going to grade you on would be the pennies. In this container, we have pre and post pennies. You're going to measure out 5 to 10 of them, of the pre, and then 5 to 10 of the post. Which one should be more dense? The pre-1982. Why? Yeah, they're what, Hunter?
There's more copper.
They're pure copper. So 182 and pre, that would be 79, 50, are all pure copper. And the ones made today are what? Copper coated. So they're going to have a different density. So I will be checking you on that. Doing this work so that if you're struggling, it's sometimes easier to see a student doing than me. It's kind of like a motivator. Yeah, every day. YouTube. Yeah, my account, David Steinecker. Very, very good.
What is it called?
Oh, it's a cylinder, black.
give you $1.
So go ahead and write this down if you didn't write this down. She got the 1 liter is equal to 1,000 centimeter cubed. These are the conversion factors up on the board. Right here. So the mass is 1,580 grams. Grams per centimeter cubed. Don't forget the units. In math class, they don't care about units because they just make up numbers.
Oh, good job.
Bryce, looking good.
Because once I fill this up, then we can check the mass.
All right.
Why is it
So this is a quiz problem tomorrow. This problem is coming from the book on page 38. We changed one variable in the problem. We went from 5 meters per second to 9.5. Yes?
Can you use like this size paper tomorrow?
I will provide you with a reference sheet that has the formulas on it. Now, will I give you the name next to the formula? At this level, I will. At college, they won't. So when you go to college, they'll give you a formula sheet, which looks like this. Right? This is a formula sheet. But on the formula sheet, they will not tell you a description of it. Like they're being nice here and they're saying like average velocity. Now, I'm going to give this to you because this is high school and we're trying to get you ready for that. But just be aware when you go there, you're like, yes, this is the second step. I've had the first step where it was a little easier. Okay. So did everybody get 20? Is that 24.0?
Yeah.
Okay.